Imagine you're doing a jigsaw puzzle. Your job is to make sure all of the pieces fit together to make a bigger picture. Sounds hard, right? But what if your job was to just verify if the puzzle was done correctly? Easy. You would just check if the picture was formed by the puzzle pieces. This brings us to one of the most important problems in mathematics and computer science, P versus NP, which is basically asking if problems with solutions are easy to verify or also easy to find. P, or polynomial time, stands for problems which are easy to solve and easy to verify in a reasonable amount of time by a computer. Computers use algorithms, which is kind of like a cooking recipe, to solve problems. P problems can be completed by an algorithm in a number of steps represented by a polynomial, such as n to the power of 2. P can be problems such as multiplying 5 by 3. It's easy to solve and easy to verify. NP, non-deterministic polynomial time, stands for problems whose solutions can be verified easily but may be hard to find. This means that the number of steps is represented by an exponential, like 2 to the power of n, which makes for a lot more steps, and thus a lot more time for computers to come up with solutions. A very common NP problem is Sudoku. For a computer, a 9 into 9 Sudoku grid is easy to solve, but increase that to 18 into 18, maybe 25 into 25. As you increase the number of grids, it becomes harder to solve for computers. How does P relate to NP? P is a subset of NP. Inside the NP circle is a section called NP complete. Every problem in NP can be transformed into an NP complete problem. An example of an NP complete problem is the traveling salesman problem, which is the challenge of finding the shortest yet most efficient route for a person to take given a list of specific destinations. NP complete problems are known to be the hardest problems in NP, which means that if we solve one of them, we can solve all problems in NP. This means that NP problems would be P problems. Now here's where the dilemma comes in. Is P equal to NP? A lot of problems which are NP problems are now P problems due to mathematicians finding clever algorithms to solve them. So can the same logic be applied to all NP problems? What would happen if P were equal to NP? Well, problems that were considered hard before would now have easy algorithms to solve them. This would mean that we could finally figure out the secret to protein folding, which would cure cancer. Furthermore, we would have solutions to a lot more problems. But one thing's for sure, if P did equal NP, then our world would change forever.